In today's lesson, we're going to be taking the patterns that we've been looking at in the previous lessons in our patterns to algebra and coming up with rules. And we're still going to come up with rules. We're going to look at them as a table, but we're also going to look at them graphically. So we're going to try to come up with multiple representations for a single rule, right? Or a single pattern. So we'll have a rule, we'll have a visual of the pattern, we'll have a table, and we'll have a graph. So if we look at the example below, we see that we have our pattern here, these green little squares, and we see positions 1, 2, and 3. Now, it may be easy for some of you to come up with the answer or the rule right away. If not, that's okay. Let's fill in our information on a table and maybe the pattern will become a little bit clearer. So position 1, we have 4. Position 2, we have 8. 3, we have 12. So maybe now you figured out what the pattern is, and it's that we're increasing by 4 every time. So that means if I had the fourth one should be 16. Right, and again, if we look at our pattern visually, we can see that we add on this kind of set of 4 squares every single time. So we'd add another 4 on for the next position and so on. Now, we might be able to look at the two columns similar to our input and output and say, well, I know that 1 times 4 is 4, 2 times 4 is 8, and so on. So I know right off the bat my rule is going to be y equals 4x, and that there's no constant. If you didn't figure that out, or you couldn't picture that or recognize that, make sure that you're not just assuming that it's always going to be 0, right? Because you can work backwards, similar to what we've done before when we found our constant. If I work backwards in my pattern to get to position number 0, what would be left over? And in this case, if I reverse the pattern and I subtract 4, I would be left with nothing. So that means my rule would technically have a plus 0 as my constant, but because I don't, or the plus 0 doesn't do anything, I don't need to actually show that. So this is my pattern, or this is my rule that I've come up with for this table, and now I'm going to graph it. Right? So position 0, there was 0, so I can put a dot down here in the corner. At 1, it's 4. At 2, it's 8. At 3, it's 12. And at 4, it's 16. So that's my pattern there. And now I've graphed it visually. So I have 1, 2, 3, 4 different representations for one single pattern. And they all mean the same thing. And hopefully we can get the same information from all of them. So in the next part, you're going to do some work either on your own, or if you have someone that you can work with, you're going to work through this on your own, and I'll explain kind of what you're doing. First, you're going to think of 3 rules that have a constant of 0. So your 3 rules have to have a constant of 0 and use a multiplier between 1 of 6. So you're going to have 3 different rules that you come up with. You're going to write out your rule, draw the first 3 positions using whatever shapes or tiles you want. Come up with how many tiles you'd have in position number 5. Do that for each of your 3 rules. And then graph the grid. And you want to make sure that you're graphing up to position 5. Right? So you do need to figure out that 5th position for all of them. And then you're going to go down and you're going to graph your 3 rules. Make sure you color code them so you can tell the difference, because there are going to be some questions on them in the next little bit. But I'd recommend you pausing the video so you can come up with your 3 rules and draw them out and determine the 5th position for them. So looking at my examples that I came up with y equals 2x, y equals 4x, and y equals 6x. So just kind of spacing them apart. Again, you may have chosen something else when you decided to do this. But again, following the restrictions of a constant of 0, so we don't see a plus anything here, and a multiplier between 1 and 6, which these follow. So I drew the first 3 positions of each one for my 3 different rules, and I determined the number of tiles at position 5. So I can see how they're changing compared to each other. I can definitely see, based on the numbers, how position 5 changes, or is different between all of them. And then I graphed each of my rules. So I can see the 3 here. Again, I color coded it. If you didn't have a different color, again, just make sure you're clearly writing or using maybe a different symbol, whether it's a square, a circle, and a triangle when you put your points down. But here we can visually see the different rules. And now what we're going to do is answer some questions based on these rules, and again, try to come up with some characteristics about our patterns. So question 1, why do you think the points form a straight line? Right, if we look back at our graph, all of our patterns form a straight line if we connect the dots or the points, or draw a line through them. So why do you think they form a straight line? Well, they do form a straight line because they increase by the same amount each time. Right, so we've seen that our patterns increase by the same amount each time. We see that visually. Hopefully we recognize that with our multiplier. That's what we're doing. Right, every position increase, we increase by the same amount. Why do you think some lines are steeper than others? So again, looking at our lines, clearly they're not all the same. Right? We can see some are steeper than others. The orange is the steepest, then the red, and then the blue. So what's unique about those different ones, right? What's unique about orange compared to the other two? And what you should recognize by looking back at your rules is that the larger the multiplier, the steeper it is. So the larger the multiplier, the steeper it is. And we have touched on that point before. So which rule made the steepest trend line? Well, in this case, it was y equals 6x, or our orange one. And which one had the flattest or shallowest line? That'd be y equals 2x. So what connections can you make between the multiplier and the steepness of the trend line? The steeper the line, the larger the multiplier. So pretty much reiterating or repeating what we talked about in number 2. The multiplier, aka rate of change, is also called, so this is going to be another term for our multiplier. We've talked about rate of change, just mentioned it before, and we can also call the multiplier the slope. Because it determines how steep a line is, slope is another word for that steepness, which we also now know as the multiplier. Another helpful term is the point where the graph crosses the y-axis is called the y-intercept, because it's crossing or intercepting the y-axis. So that's why we refer to it as the y-intercept. So that's basically where the line crosses the y-axis. So if I go back here, I see all of my lines cross the y-axis at this origin, or 0, 0. In the next part, we're going to go through, or you're going to go through with a partner. Again, you can go by yourself or work with yourself. You're going to go through and do something similar, except now we've come up with, or the rules are given to you, and you're going to graph them again and analyze them and answer some questions. So I'm going to ask you to take some time. You can pause the video and work on this, or you can just kind of wait. I'm going to fill out the tables for each one of our new rules. We're going to graph it. And then we're going to see how are the graphs different and how are they the same? So that's what we're going to focus on in this part. So once you've gone through and graphed or filled out the tables for your 3 different patterns and come up with the graphs for them, this is what you should have. So now we want to focus on, okay, how are these graphs different and how are they the same? Well, they're different. Again, we can talk about different steepness or different slopes, which we also know as multipliers. That's kind of the big difference that I see between them. You might, again, describe that in different terms. How are they the same? You could say they form straight lines. And you might also recognize they start at the same point. So they all start at the same point. They're all straight lines, but they all have different slopes or multipliers. In our next example, again, you're going to go through the same thing. You're going to fill out the table, and you're going to graph them and identify what's different about them and what's the same about them. So again, similar to what we just did in the last one. So after you fill out the tables and after you've graphed them, this is what you should find. You should see that we have them all graphed with our lines. So again, now we want to figure out what's different and what's the same about them. So what's different about them, they start at different points. Right, because we see they all have a different starting point. How are they the same? So by looking at them, we could say that they're all straight lines. Visually, we can see that. And if you took a closer look, you might also say that they are parallel. Or you could say parallel kind of means the same, or you could say same slope or same steepness. Right? They're not increasing or decreasing by a different amount. Because we all see they all look basically the same type of slope or the same steepness, just shifted up or down or higher or lower depending on a specific value. So again, looking at these graphs, that's what we kind of want to look at and see how are they different. And if we go back and we look at the actual rules, we can see that the difference here is the constant. So the constant affects where it's starting. And where it's starting is along the y-axis. Remember, y is the vertical. And we've talked about before that the point where a line crosses the y-axis is called the y-intercept. So when they start at different points, that's basically saying they have different y-intercepts. Or in other words, we also know that last number to be a constant. So they start at different points, which basically means they have different y-intercepts or constants. If they have the same multiplier, it means they have the same slope or steepness, which we could call parallel. And we see that in the first example of part 2 that we did. The constants were all the same, so the starting point is the same y-intercept or constant. And we've already talked about the different multipliers being the different slopes. So again, recognizing that the multiplier or the slope determines the steepness of it. If we have the same slope like we see here in number 2, we would call those lines parallel. And the constant represents the y-intercept, which is where the line crosses the y-axis. So again, more new terminology, but just representing the same thing that we've seen before in the past with these patterns and rules, but now, again, the different descriptors now that we're looking at them graphically. So again, just make sure you understand this new terminology and understanding what it represents in the patterns and rules that you already know.